Hello students, welcome to EPG Pathshala. I am Dr. Renu Tyagi from Sardar Patel Institute, Ahmedabad. Today we'll talk about the module Nutrition, Doping and Performance under the paper Physiology and Sports Anthropology. So the students in this module will be able to understand the objectives like the general nutrients of the diet, nutrition and how it affects the performance of an individual. We'll be studying the energy requirement of different type of sports. We'll define what doping is and what are its effect on the body. We'll study the different types of doping, the different types of stimulants and their effect on the sports performance. Now let's see what is nutrition. Nutrition is, as we all know, is the intake of food considered in relation to the body's dietary needs. Good nutrition, as we all know, is an adequate, well-balanced diet combined with the regular physical activity, which is a requirement of a good health. The poor nutrition can lead to the reduced immunity, increased susceptibility to the diseases, impaired physical and mental development and the reduced productivity. A basic understanding of nutrition and its effect upon the health, weight control and physical performance is important for all the people, including the coach, trainer and athlete. An athlete's performance may be improved with the good and balanced nutrition, while at the same time it may decline or it may be responsible for the poor nutritional practices. The general nutrients in the diet are classified as carbohydrate, fat, proteins, vitamins, minerals and water. Now let's see the carbohydrate. The main function of the carbohydrate is to furnish the energy to millions of cells within the human body. The carbohydrate can be classified as monosaccharides, disaccharides or polysaccharides. The most common monosaccharide carbohydrate is glucose, which can be oxidized and used directly by the body fat for energy, or it may be broken down by the digestive system and converted into glycogen and stored in the muscles and liver for the later use. However, if it exceeds for storage capacity for glycogen in the muscles and liver, the excess glucose is converted into fat and stored in the fatty adipose tissues of the body. Therefore, if a person is on high carbohydrate and low fat diet, it is still possible for that person to increase his or her fat level. The fat have several major functions in the body, such as energy storage, which can be used as a fuel as the body needs it, carrier for the soluble vitamin A, D, E and K throughout the body. The fat is a soft cushion against inside and outside the shock or blows to the vital organs such as the heart, lung, kidneys, liver, spinal cord, etc. Heat insulator to protect the body against the cold weather. And fat helps in retarding or depressing the hunger pangs. Fat molecule consists of the carbon, oxygen and hydrogen. It contains lesser oxygen and more carbon and hydrogen than carbohydrates and act as a greater fuel provider but has a greater oxidation cost. Chemically, a fat molecule is made up of fatty acids and cholesterol. The fats are stored in the body in the form of triglycerides. The next category is protein, which contains nitrogen in addition to the carbon, oxygen and hydrogen. Proteins are basically the building block of the tissues, so every cell in the body needs protein. They furnish the basic material for the muscular contractions. Proteins made up of nitrogenous compounds called amino acids, which are of 20 different types. Out of these, 8 are essential and not synthesized within the body. The essential amino acids are obtained directly from the diet, and these are named as isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan and valine. Vitamins are the organic substances that are essential for human life. The living cell cannot manufacture vitamins, so they must be provided either in the diet or by the way of supplements. They can be classified as either water soluble or fat soluble. The fat soluble vitamins are composed of carbon, hydrogen, and oxygen, whereas the water soluble are containing the nitrogen, cobalt, and sulfur in addition to the carbon, hydrogen, and oxygen. The fat soluble vitamin can be stored in the body, whereas the water soluble vitamins are not capable to be stored in the body. The minerals, like vitamins, provide no energy. However, each mineral has a diverse function which is important for the proper functioning of the body. Minerals are found in the bone, teeth, muscles, cells, and connective tissue, body fluids, and also in vitamin, hormones, and enzymes. They make up about approximately 4% of the body weight. The mineral deficiency of any type of mineral can lower an athlete's efficacy. Depleted minerals during exercise can be replaced by the diet or through the supplements. Water, which makes about 40 to 60% of the total body weight, is not classified as an energy nutrient. However, the function of water is to provide a medium for all chemical processes to take place in the body. Besides, it also assists in forming the blood plasma, digestion of food, granular secretion, and in waste elimination. Let's see the nutrition and their role in the performance. During the times of high physical activity, energy and macronutrients needs, especially those of carbohydrate and proteins intake, must be met in order to maintain the body weight, replenish the glycogen stores, and provide adequate protein for building and repair of the tissue. Fat intake should be adequate to provide the essential fatty acids and fat-soluble vitamins, as well as to help provide adequate energy for the weight maintenance. Overall diet should provide moderate amount of energy from fat to about 20 to 25% of the energy. Body weight and composition can affect the exercise performance, but should not be used as the sole criteria for sports performance. Daily weighing should be discouraged. Consuming adequate food and fluid before, during, and after exercise can help maintain blood glucose during exercise, maximizes the exercise performance, and improves the recovery time. An athlete should be well hydrated before beginning to the exercise. Athletes should drink enough fluid during and after the exercise to balance the fluid loss. Consumption of the sports drink containing carbohydrate and electrolyte during exercise will provide fuel for the muscles, help maintain the blood glucose and the thirst mechanism, and it decreases the risk of dehydration or hyponatremia. Athletes will not need vitamin and mineral supplements if adequate energy to maintain body weight is consumed from a variety of the food. Though the supplements may be required by athletes who restrict the energy intake, use severe weight loss practices, eliminate one or more food groups from their diet, or consume high carbohydrate diet with low micronutrient density. Research has clearly documented the beneficial effect of nutrition on exercise performance. There is no doubt that when an athlete eats and drinks can affect the health, body weight, and body composition, substrate availability during the exercise, recovery time after exercise, and ultimately exercise performance. The increase in the interest and the research in the sports nutrition has resulted in the increase in the sale of ergogenic aids, supplements, herbal preparations, and diet aids. The manufacturers of these products frequently make unsubstantiated claims to entice the athlete to use their products. The athletes who wants to optimize exercise performance need to follow good nutrition and hydration practices, use supplement and ergogenic aids carefully, minimize severe weight loss practices, and eat a variety of food in adequate amount. This position is focused on adult athletes rather than children or adolescents and does not focus on any particular type of athlete or athletic event. Moreover, the position is intended to provide guidance to dietetics and health professionals working with the athletes and is not directed to individual athletes themselves. Energy requirements. Meeting the energy needs is the first nutritional priority for the athletes. Achieving energy balance is essential for the maintenance of lean tissue mass, immune system, and reproductive functions, and to have the optimum athletic performance. Energy balance is defined as a state where energy intake, that is the sum of energy from food, fluid, and supplements, equals the energy expenditure, that is the sum of energy expended as the basal metabolism, the thermal effect of the food, and any voluntary physical activity. Inadequate energy intake relative to the energy expenditure compromises the performance. With limited energy intake, fat and lean tissue mass will be used for the fuel providing to the body. The loss of muscles result in the loss of the strength and endurance. In addition, chronically low energy intake often results in the poor nutrient intake, particularly of the micronutrients. In the year 1989, Recommended Dietary Allowance, that is RDA, by the National Research Council in 1989 means that energy requirement for women and men who are slightly to moderately active and between 19 to 50 years of age was established as 2200 and 2900 kilocalorie per day respectively. For athletes, the recommendation is made to evaluate the kind of exercise performed for its intensity, frequency, and duration, and then to add this increment to the energy needed for the normal daily activity. For example, a 70 kg male runner who runs 10 miles per day at a 6-minute pace would require approximately 1063 kilocalorie per day to cover the energy expenditure of running of 0.253 kilocalorie per minute per kg, plus the energy cost of the normal daily activities, which is 70 kilogram 337 to 41 kilocalorie per kg per body weight for the normal activity. Ultimately, however, numeric guidelines for energy intake, such as those cited here, a crude approximation of the average energy needs of an individual athletes. Any athlete needs to consume enough energy to maintain appropriate weight and the body composition while training for a sports. Usually, energy intake for male endurance athletes range from 3000 to 5000 kilocalorie per day. Although usual energy intake for many intensely training female athletes may match those of the male athletes per kg of the body weight, some consumes less energy than they expend. Although resistance exercise usually require less energy than endurance exercises, the total energy needs of athletes participating in strength training and bodybuilding may be as high as those of the endurance athletes because of their increased body size and high levels of fat-free mass. In circumstances in which an increase in the lean body mass is the goal, energy intake must be sufficient to meet the needs for the muscle's growth. Therefore, many strength athletes may need 44 to 50 kilocalorie per kg body weight, and those in the serious training may even need higher energy requirements. The American Dietetic Association, Dietitians of the Canada, and the American College of Sports Medicine stated that the physical activity, athletic performance, and recovery from exercise are enhanced by the optimal nutrition. These organizations recommend appropriate selection of food and fluid, timing of the intake, and supplement choices for optimal health and exercise performance. During the times of high intensity training, adequate energy needs to be consumed to maintain the body weight, maximizing the training effects and maintain a health. Low energy intakes can result in the loss of muscle mass, menstrual dysfunctions, loss or failure to gain the bone density, and increased risk of fatigue, injury, and illness. Body weight and composition can affect the exercise performance but should not be used as the sole criteria for participation in sports. The optimal body fat level vary depending upon the sex, age, and heredity of the athlete as well as the sports itself. Body fat assessment techniques have inherent variability, therefore limiting the precision with which they can be interpreted. If weight loss is desired, it should start early before the competitive season and involve a trained health and nutrition professional. Carbohydrates are important to maintain the blood glucose level during exercise and to replace muscle glycogen. Recommendation for athletes range from 6 to 10 gram per kg body weight per day. The amount required depend upon the athlete's total daily energy expenditure, the type of sports performed, gender and the environmental conditions. Protein requirements are slightly increased in high active people. Protein recommendation for endurance athletes are 1.2 to 1.4 gram per kg body weight per day, whereas those for the resistance and strength trained athletes may be as high as 1.6 to 1.7 gram per kg of body weight per day. These recommended protein intake can generally be met through diet alone. Fat intake should not be restricted because there is no performance benefit in consuming a diet with less than 15% of energy from fat compared with 20% to 25% of energy from fat. Fat is important in the diet of athletes as it provides energy, fat-soluble vitamins, and essential fatty acids. Besides, there is no scientific basis on which to recommend high-fat diet to the athletes. The athletes at greatest risk of micronutrient deficiencies are those who restrict the energy intake or use severe weight loss practices, eliminate one or more food groups from their diet, or consume high carbohydrate diet with low micronutrient density. Athletes should strive to consume diet that provides at least the RDA for all micronutrients from the food. Dehydration decreases exercise performance. Therefore, adequate fluid before, during, and after exercise is necessary for the health and the optimal performance. Athletes should drink enough fluid to balance their fluid losses. 2 hours before exercise, 400 to 600 ml of the fluid should be consumed, and during exercise, 150 to 350 ml of fluid should be consumed every 15 to 20 minutes depending upon the tolerance. After exercise, the athlete should drink adequate fluid to replace the sweat loss during the exercise. The athlete need to drink at least 450 to 675 ml of fluid for every pound of the body weight lost during the exercise. Before exercise, a meal or a snack should provide sufficient fluid to maintain the hydration, be relatively low in fat and fiber to facilitate gastric emptying and minimize gastrointestinal distress, be relatively high in carbohydrate to maximize maintenance of blood glucose, and be moderate in protein and should be composed of food familiar and well tolerated by the athlete. During exercise, the primary goal for nutrient consumptions are to replace the fluid losses and provide carbohydrate for the maintenance of the blood glucose level. These nutrition guidelines are especially important for the endurance event lasting longer than an hour. After exercise, the dietary goal is to provide adequate energy and carbohydrate to replace the muscle glycogen and to ensure rapid recovery. If an athlete is glycogen depleted after exercise, a carbohydrate intake of 1.5 gram per kg body weight during the first 30 minutes and again every 2 hours for 4 to 6 hours will be adequate to replace the glycogen stores. In general, no vitamin and mineral supplement should be required if an athlete is consuming adequate energy from a variety of foods to maintain body weight. Supplementation recommendation unrelated to exercise, such as folic acid in women of childbearing potential, should be followed. If an athlete is dieting, eliminating foods or food groups, is sick or recovering from an injury, or has a specific micronutrient deficiency, a multivitamin or mineral supplement may be appropriate. No single nutrient supplement should be used without a specific medical or nutritional reason. Athletes should be counseled regarding the use of ergogenic aids, which should be used with caution and only after careful evaluation of the product for safety, efficacy, potency, and legality. Vegetarian athletes may be at risk for the low energy, protein and micronutrient intake because of high intake of low energy dense food and the elimination of meat and dairy from the diet. Consultation with a registered dietitian will help to avoid these nutritional problems. Let's see what is doping and the impact of doping on the performance of an athlete. Doping is the use of the performance enhancing drugs in sports. The use of these drugs is mostly done to improve the athletic performance. The use of drugs to enhance the physical performance has been observed for thousands of years. And the goal of the user most often was to increase the strength or to overcome the fatigue. Today, we classify such drugs as anabolics and stimulants. A number of performance enhancing drugs, including the anabolic steroids, are not mood enhancing immediately after the administration. Instead, the appetite for these drugs was created predominantly or due to our societal fixations on winning and physical appearances. The word doping had become part of the English dictionary in 1933 only, while Reiser and others continued to speak out against the doping. The doping was not used in 1967 that the International Olympic Committee IOC voted to adopt a drug testing policy banning the use of specific drugs. Children play games for the fun, but the society preaches the importance of winning, seemingly at an increasingly younger age. Ours is a culture that thrives on competition, both in business as well as in sports. However, we long ago realized that the competition of all type could exist within some boundaries or with some rules. In fact, sports itself is defined by the boundaries, that is the rules. A primary goal of competition is to win or to give your very best in any endeavor. Philosophically, many in our society appears to have taken a bottom line attitude and consider winning to be the only truly worthwhile goal of the competition. Thus, win at any cost winner take off philosophy is not new. It dates back to the ancient Greek Olympics. In addition, a number of professional wrestlers such as the Hulk Hogan and Stone Cold Steve Austin, as well as some other athletes such as the professional basketball players Mark McGuinn, were admired in part for their performance or larger than life muscularity. The anabolic steroids used among the professional wrestlers, including the Hulk Hogan, was given the national attention during a steroid trafficking trial in 1991. Now let's have a look at the type of doping. As we can see from this picture, the three types of doping are specified here, that is blood doping, amphetamines and anabolic androgenic steroids. Now let's see what is blood doping. Blood doping is defined by the World Anti-Doping Agency WADA as the misuse of techniques or substances to increase one's RBC count. This is done because RBCs help to carry oxygen to the muscles and therefore increase the stamina and performance. Blood doping started in 1970s and was not outlawed till 1986. However, the blood doping was banned by International Olympic Committee (IOC) in 1985. The autologous blood doping is the most commonly involved the removal of 2 units of the athlete's blood several weeks prior to competition, which is frozen and stored. A day or two before the big event, the stored blood is thawed and re-injected into the athlete's system. Allogenic or homologous blood doping is the process of injection of fresh blood removed from a second person into the athlete's system. Another way is the use of hemoglobin-based oxygen carrier. The hemoglobin is the protein contained in the RBCs that loads the oxygen in the lungs and delivers it to the tissues. This has been developed for the therapeutic use, however, it is now being misused as the performance enhancer. Let's see the effect on the performance. Blood doping is most commonly used by the endurance athletes such as distance runners, skiers, and cyclists. By increasing the number of RBCs in the blood, higher volume of the protein hemoglobin are present. Hemoglobin can bind and carries oxygen from the lungs to the muscles where it can be used for aerobic respiration. Blood doping therefore allows extra oxygen to be transported to the working muscles, resulting in a higher level of performance without the use of anaerobic energy system. Some of the side effects of the blood doping include the increased blood viscosity, increased chances of myocardial infarction, increased risk of pulmonary embolism, that is a blockage which can be fat or a blood clot in the pulmonary system, increased risk of cerebral embolism, that is a blockage formed in the body which becomes lodged in an artery within or leading to the brain. It may lead to cerebrovascular accidents. It may lead to more chances of infection. In addition to these, athletes undergoing the blood transfusions are prone to further side effect with the allergic reaction or risk of contracting the blood-borne disease like hepatitis C, B, and HIV. Let's see the stimulants. Continuing the practices of the 19th century counterparts, athletes during the first 3 decades of the 20th century used a variety of substances like alcohol, cocaine, styrosine, caffeine, and nitroglycerin for their purported stimulant effects. Noticeably absent from this doping menu is any mention of the use of amphetamines, even though they were first synthesized in 1887. In 1920s and 30s, other derivatives of amphetamines were synthesized. However, it was not until the mid-1930s that amphetamines were identified as a central nervous system stimulants. And in 1937, they became available as a prescription tablet. The first systematic use of amphetamines as an ergogenic aid is seen during World War II, when both Axis and the Allied powers used these drugs to combat fatigue and improve endurance. The British Army used amphetamines when men were markedly fatigued physically or mentally and circumstances demanded a particular effort. According to a report in the Air Surgeon's Bulletin 1944, one pill of benzedrine may be worth a flying fortress when the man who is flying it can no longer stay awake. Going beyond staving off fatigue, the Japanese were said to have used heavy doses of amphetamines to arouse or psych up their pilots in preparation for their suicide missions. Similarly, Mendel in 1981 suggested that amphetamines could be used by soldiers to create a sense of fearlessness. The amphetamines are stimulants which act on the central nervous system (CNS) to delay the fatigue and increase the alertness. They are also capable of increasing a person's speed, power, endurance, and concentration. However, there are many side effects of using the amphetamines. The use of amphetamines is associated with the addiction. Athlete can become dependent on the drug, resulting in the long-term use and higher risk of more severe side effects. The short-term use of amphetamines can produce the effects like cerebral hemorrhage, confusion, hypertension, angina, vomiting, abdominal pain, irritability and restlessness, insomnia, dizziness, or tremors of the body. The anabolic steroids are sometimes known as anabolic androgenic steroids AAS, which are derived from the hormone testosterone. Steroids are most commonly used by the athletes involved in the power sports like weightlifting, throwing and sprinting events. Field sports such as football and rugby also demonstrate a high incidence of use as in bodybuilding. In 1920s, serious concerns arose in the medical community regarding their overt claims of rejuvenation. As a result, an international committee was appointed to evaluate these claims and concluded that they were unfounded. The practice disappeared by 1935 when scientists isolated, chemically characterized, and synthesized the hormone testosterone and elucidated the basic nature of its anabolic effect. Shortly thereafter, both oral and the injectable preparation of testosterone were available to the medical community. While there is no record of systemic use of testicular transplants or the injections of the testicular extract by the athletes, these procedures likely helped lay the foundation for subsequent use of testosterone as an ergogenic aid. It has been rumored that some German athletes were given testosterone in preparation for the 1936 Berlin Olympics. Furthermore, the Nazis were opposed to organism-altering drugs in general. There was a concerted campaign against the poisons, alcohol and tobacco, and the Nazis were not particularly interested in the popular gland transplant technique of that period, since their idea of race improvement was genetic. Let's see the effect on the performance. The perceived benefit include the increased muscle bulk, increased muscle strength, faster muscle recovery, and reduced muscle catabolism. However, the sum of side effects of these drugs are increased aggressiveness, irritability and mood swing, liver disorders, hypertension, baldness, raised cholesterol level, development of oversized mammary glands in male, menstrual irregularities among females, reduced immunity, possible development of tumors, decreased sperm production in males, and excessive facial hair growth occurring in females, which follow the pattern of male hair growth. Now let's summarize what we have understood in this particular module. We have understood what good nutrition is. A good nutrition is an adequate and balanced diet combined with the regular physical activity results in the good health of an athlete. A basic understanding of the nutrition and its effect upon the health, weight control and the physical performance is very important for all associated with the sports, including the coach, trainer and the athlete. An athlete's performance may be improved with good and a balanced nutrition. Meeting energy needs is the first nutritional priority for the athlete. Achieving energy balance is essential for the maintenance of lean tissue mass, immunity and reproduction functions and optimum athletic performance. Before exercise, a meal or a snack should provide the sufficient fluid to maintain the hydration. So, the diet should be relatively low in the fat and the fiber to facilitate the gastric emptying and minimize the gastrointestinal distress. It should be relatively high in the carbohydrate to maximize the maintenance of blood glucose. The diet should be moderate in the protein and be composed of the food which are familiar and well tolerated by the athlete. During exercise, the primary goal for the nutrient consumptions are to replace the fluid losses and to provide the carbohydrate, which should be approximately 30 to 60 grams per hour for the maintenance of blood glucose level. On the other hand, after the exercise, the dietary goal is to provide the adequate energy and carbohydrate to replace the amount of glycogen and to ensure the rapid recovery of the athlete. The athletes should be counseled regarding the use of ergogenic aids, which should be used with a caution and only after a careful evaluation of the product for its safety, efficacy, potency and the legality. We have learnt about the doping also. As we all know, doping is the use of performance enhancing drugs in sports. The use of these drugs is mostly done to improve the athletic performance. The blood doping is defined by the World Anti-Doping Agency WADA as the misuse of the technologies or the techniques to increase the one's RBC count. This is done because RBC helps to carry the oxygen to the muscles and therefore increase the stamina and the performance of the individual. The blood doping started in 1970 and it was not outlawed till 1986. The blood doping was banned by the International Olympic Committee IOC in 1985. Another type of performance enhancing drugs are amphetamines or the stimulants, which are actually used due to their ability to combat the fatigue and improve the endurance. The anabolic steroids, which are generally known as the anabolic androgenic steroids or AAS, derived from the hormone testosterone. These steroids are most commonly used by the athletes involved in the power sports like the weightlifting, throwing and sprinting events. The field sports such as the football and rugby also demonstrate a high incidence of usage of these drugs for the body building. However, the short-term benefits of such drugs cannot hide their harmful effects, which in the long run may even be fatal to the user, so these should be avoided. Thank you.